My name is Donald Frazier, and my current position is that I'm a emeritus scientist working in tech transfer in the Science and Technology office. My formal training is that I'm a physical chemist. I have a PhD in physical chemistry from Rutgers, and I've worked in this area throughout my entire career, which actually officially ended in December of 2012, and I came back in retirement to do this additional work that I'd like to do to help advance technology with HBCUs, historically black colleges and universities, and small colleges, and with some advanced technologies. Born in Nashville, but moved to Detroit ultimately after a brief stint in Los Angeles, and grew up in Detroit. And my early years in Detroit were that as a young boy who was just going from day to day and making sure I was getting some of my mom's good cooking and trying to do the right things to satisfy my parents, and staying out of trouble, and sometimes not always successful at that, and growing up in Detroit. Now, as far as how I got interested, and this is a story that I like to tell because it really played a little bit of a role in my future work, is my parents gave me a chemistry set when I was a child, which I really enjoyed. I liked that. They didn't know I was going to like it as much as I did, but I liked doing that, playing with that. And the other thing they wanted me to do was burn the trash, and we had alleys in Detroit that was how we got rid of our weekly trash. We didn't have, I don't remember seeing any regular garbage pickups, and they might have come in the alley somewhere along the line, but generally it was going out and burning the trash and leaving all the ashes back there somewhere. And I was fascinated by what was going on in a combustion process. I wasn't calling it that then. Then I was calling it burning the trash. But I came to realize that this was a process that required oxygen, and it was combustion, and it had some other meanings to it. And I slowly learned that rusting and corrosion was a similar process of the same process of oxidation, and except it not as exothermic. It didn't give off the heat, and it was much slower. And so I said, well, this is something else. And finally, I came to realize that this is relevant to even electrochemistry, which is even more subtle and nuanced, and which is not which could involve oxygen, but just got me into oxidation reduction processes, which is a form of physical chemistry. So I became interested in physical chemistry. Then later on, I was teaching up in SUNY before I got my PhD, but while I was working on it, I went up to State University of New York at Albany, and got involved in a program which tried to encourage young people to get into chemistry and the sciences. And so this was beginning of my interest in STEM. And I started thinking about this combustion process that I was involved in as a kid. So what if you don't have oxygen, you put heat into it? And so, what you have is pyrolysis. And so if you do that, if you take garbage and stuff that's biodegradable and burnable and all that, but you exclude oxygen, you can do that using what's called a tube furnace, flow nitrogen over it, and just raise the temperature real high. Those molecules can fly apart, and they come back together and form crude oil. And so we started getting kids to doing that up in State University of New York at Albany. And I found out that there is a company there was a company, this is back in the 70s, a long time ago, called Occidental, who also had that same idea and were converting garbage to oil in that way. And now, you don't get crude oil as it comes out of the ground, but you get certain fractions of crude oil depending on what you burn. So we had students taking the moisture out of garbage, banana peels, you name it, any kind of garbage, grinding it up to make a powder and putting in tube furnaces and taking it up to temperature. Absent oxygen, it comes back together, you cool it down, and it forms crude oil. And so these are ways, these students became very excited. Now, these aren't students that you would normally expect to jump on and get into the science field, but the idea that they were striking oil from something they were very familiar with was extremely exciting to them. So we started doing other things. By the way, Occidental, I think, did build some plants somewhere in the Soviet Union and Russia. Somehow they got involved with them, and I don't know what the status of that is or not, if there's too much energy involved for it to be really an effective way to develop oil. And you don't get the same fractions. You get certain fractions depending on what you start with, what your starting point is. But you might be able to make butane, cigarette lighter fluid. You might be able to make candle wax. You might be able to make some other petroleum products other than gasoline. Oh, you might be able to make gasoline if you got the right combination of things. But it's an interesting thing that touches kids and students in general into an idea that that maybe they can do something, they can really think through some things that are familiar to them and come to some, if they have the right training. And so that's where, to me, STEM comes into the picture, into the process, by getting people involved by introducing them to something that is familiar to them. The other thing that and this is not, this is typical of anybody, you might want to, the other thing, along those lines, we decided is, yes, what about it? What if we wanted to have an insecticide? What if we wanted to, and this is not to say that a certain class of people have roaches or anything. Everybody sees a roach every now and then. And we know that that's a problem. That's a pesticide. We do a lot of development in the industry. What if you got around the immunization process, or the fact that you can spray insects enough so they become immune, future generations become immune, they build up an immunity to that particular chemical. Well, what you'd want to do is sterilize them. So we started thinking about attracting them using pheromones, which is a sex attractant, to attract, let's say, the male to the female, and then doing some chemical synthesis, organic synthesis, synthesizing something. This is all something that teaches, this is part of a STEM process, teach them something that would sterilize them, chemosterilant. There were a lot of chemosterilants out that were used on fruit flies and that. So we ended up getting some formulations, and the students would get into the lab and make these things. And then we would set up a thing where we would find the female, we'd have to identify the female insect and the male insect, then we'd attract the male insect and then feed them these chemosterilants. Sure enough, there were no future generations. And you're talking about exciting some students. These things worked elegantly. And there were other ideas. We used other things with art and polyurethanes and that sort of thing. So STEM education, I think, is something that needs to at least start with familiarity, something that the students are familiar with. And this is not all students. There are some that are just innately, ready to learn whatever without any kind of stimulant or creativity. But then there's a large fraction that will learn it if you provide them with the right incentive. And I think we need to do more of that. The biggest part, I think, is a thing that limits us in this whole STEM process is resources, our resources. You know, we don't provide the right amount of resources. I mean, things like I just described still requires somebody to do it, someone to teach it, someone to pay for it. I think until we are committed to providing the right amount of resources and the right amount of direction, the right amount of incentives for the students to pick it up, you know, we're going to be fighting these fires, I think, a little bit randomly. I know when I was a kid, one of the things, not when I was a kid, when I was in college, one of the things I understood that separated the teaching curriculums from science curricula, or that the education curricula, and this is years ago, and I think they have improved on that by now, the education curricula didn't require science, didn't require mathematics. So the teachers were who chose education as their pathway to a degree, were doing it largely because they wanted to avoid science and mathematics. And I had a few friends like that, so I know that was the case then. Now, I know that's improved now, but it's just an example of what happens to a student who is being taught by someone who is afraid of the topics, the STEM topics. That student is not going to learn, so you propagate that same fear in the students, or aversion to the topic. The student might be ever so inclined to want to learn that topic, but there's no one available to introduce it. So that was then. I think now they've corrected that. But even now, I believe the pay for a STEM teacher is probably no better than the pay for any other teacher. And although all teachers are great, don't get me wrong, you know, art, all that is wonderful stuff. It's just that there's a short change when it comes to STEM education, just naturally. I think that anyone who is knowledgeable about engineering, science, technology, and mathematics is going to migrate, obviously, to the highest paying job. And that's generally the case. There are going to be some that are dedicated and willing to do things out of their own pockets and for free. Though that's a rare individual, laudatory individual, but it's not the masses that we need in order to move STEM education forward. What I'm doing now as an emeritus is free of charge. I don't get paid to be an emeritus. I don't know how many people would do that. I'm not saying that there's something special about me, but it's going to require either resources or someone who is saying they don't require resources to do it. What we're doing is writing proposals. It is something for his career. Trying to get funded to do some very forward-thinking research, what we call low technical readiness level work, low TRL. Trying to, and he has connections in turn. He got his PhD from Vanderbilt, but he also has connections to smaller schools and HBCUs, historically black colleges and universities. So he can tie into those. And so what we're trying to do is develop a network of small schools, including especially HBCUs and OMUs, other minority universities, Latino universities, Hispanic, Native American, and to develop work in conjunction with perhaps some of the larger universities like Berkeley, Harvard, Carnegie Mellon, to do some low technical readiness levels so that students that need maturing, a time to mature and develop because of this lack of STEM education, they might need a little time. And hopefully that development and technology development can converge at some time in the future, at which time we would have a highly educated workforce from this particular set of students and technologies. I think if that can be things like that, and that's just one idea. I presented that to Dr. Julian Earls last week, actually, who is the former director of the Glen Research Center. And he's doing some remarkable things himself as a retired director. He is a product of an HBCU. He came out of Norfolk State University. And he's done many other things since. He's been through the Harvard Business School and so on. Julian Earls is very well known in physics. And he was very supportive of this idea of retirees going back into the where they came from on some of these unpaid positions, such as an emeritus position, and which that's that's not something that's going to be done in by a large number of people, because most people would like to increase their retirement earnings, by doing something that they get paid for, compensated for. And not to say that I wouldn't eventually do that myself, but just as a possible avenue, getting back and getting some of these young PhDs involved in this, which helps their career, helps them navigate through full cost accounting and line management, because now you've got somebody who is free to go around and develop partnerships within the organizations, within the institution, and among the universities, which you wouldn't normally have that time to do it if you were in an 8-to-5 job and expected to deliver. For example, if you're on the SSL team or some team that has deadlines to meet, there's no time for the person who is working an 8-hour day in his organization to do all of these extra things. And this is what I mean by we have a lack of resources and infrastructure to really approach STEM on the level that we need to approach it. And so, what I'm doing is right now, in this emeritus role that I'm playing, is to try to find a process whereby we can encourage certain people to come back and mentor, and gets into the mentoring on another level. Mentor already developed PhDs and people that are advanced but are constrained by the institution to do these things outside of the bounds of what they're expected to do. And I'm working with a young man, Dr. Enrique Jackson, right now, who is, this is the person I was talking about, who has his PhD, who is willing to he is very energetic and capable, and is making some of these connections that I think he had Jackson State up today in a meeting with the folks in Tech Transfer. So this is something that needs to be thought about and looked at. Not to say that I'm providing the perfect solution, but at least it should be something that could be discussed and considered. Most of my teaching was at Oakwood. I taught I started physical chemistry years ago at Oakwood College, and at least I had something to do with the start of physical chemistry at Oakwood College, and that's where I did most of my teaching. Now, at A&M, I, along with Dr. Benjamin Penn, another PhD he's a polymer chemist at Marshall Space Flight Center, helped develop the physics department at Alabama A&M, which had really rose to become one of the top physics departments at the time in the country. Even now, they have a Nobel Prize speaker every year to come called this Venkateswarlu, Pucha Venkateswarlu Nobel laureate series. They come once a year to Alabama A&M, somewhere around this time of year, actually, October, November time frame, and give a lecture. That department started years ago with our support from Marshall Space Flight Center, and Dr. Benjamin Penn and myself were the ones that did most of that work. First of all, I started from scratch, and second of all, I couldn't do it on Saturdays because it's a 7-day Adventist school, and so I had to do things like set up a laboratory for enough students. There were something like 12 or 13, 14 students. I had to have enough experiments, and I had to do the lectures. We met every week. Classes were I had 2 lectures, about an hour and a half per lecture, I guess, and then I had a lab that was about 3 hours long. And so what I did was I accumulated experiments. I went over to UAH and got some of their experiments. I went out to A&M and got some of their experiments and put them all together, got my own set of ideas, and developed a bunch of experiments that the students had to work their way through. And we got the equipment. We had some equipment. I had some equipment already there. Dr. Lahing, who was another physical chemist, said, "Oh, he's the main guy there now," or he was. And he had helped with some calorimeters and various pieces of equipment that were there, and we set it up, and they did write the hours to match my work schedule, and I'd come down after work here at Marshall and run the lab and do the lectures. And so I did that for about 6, 7 years at Oakwood, and so that was a very, very good experience, because some of those students became extremely talented and went on to medical school. And one of them she found out from me she didn't really like chemistry, so she became a lawyer, and she became the chief counsel here at Marshall Space Flight Center. Highlighting the idea that, you hear about the history of minorities, black folk, being unsuccessful in the sciences and that sort of thing is a myth. It's a myth. I think there are many extremely talented Charlie Bolden, our NASA leader, Ron McNair, Guyan Bluford, who flew Challenger before Ron McNair flew Challenger. It didn't blow up on him, but in 1983 he was the first black astronaut, and did some wonderful things out there. Carruthers, who was the first guy who developed the spectrograph that recorded our atomic oxygen around the Earth from the lunar surface. He did all the instrumentation for that. These are all blacks that are extremely gifted and who have come out of similar situations that I came out of. We go all the way back to what makes anybody successful at what they do. You have to go back to familiarity and surroundings, and not innate ability, but surroundings. What is it that they're most familiar with? And we talk about great black athletes and all that. Well, when I was a kid, that's all I did was play basketball at the playground down the street. I couldn't go swimming because there were no swimming pools, you know. So there's the myth about swimming, you know, black folks can't swim. Now we have Olympic swimmers, you know, because now they're exposed to it more. And so exposure is what the problem is. And I maintain that if we have the resources, and I keep coming back to resources, and that's why I'm doing this, what I'm doing now with the emeritus thing. I consider this, that I'm being a resource. We go back to resources and funding teachers who can teach STEM more than, or giving them something that keeps them from going off into engineering fields. Help them get into education fields. Help make some incentive out of it, and they might be more inclined to do that than working in an organization like Marshall or anywhere else. They might want to work in a school and help students, pay them, and so resources is the thing that we need to put more into. It's nothing magical about STEM. We talk about STEM like there's something, you know, mysterious. You know, it's not mysterious, you know. People used to tell me when I was coming up through the sciences, don't take physical chemistry because it's hard. Well, I already knew I liked physical chemistry, you know, because of the burning, combustion stuff. Yeah, I knew I liked to look at and look at oxidation reduction reactions, you know. So why should I avoid it? And but the general feeling is that, oh, this is too difficult, or this is not something for them. It's like the swimming thing. It's not too difficult to swim. I can't swim because I didn't have a swimming pool. I got one now, but I didn't have one then. And my kids are some of the best swimmers you can find. My kids are. And so it's a matter of exposure, and that's what limits us. And then we get tangled up in so much noise, you know, about things that aren't important, that aren't correct, that miss the point. And in the meantime, our human resources, which are the African Americans, Latinos, all these people that could be really contributing big time to our society, are left struggling with things that they don't quite understand because they haven't matured to the point to understand it, and we don't give them the opportunity. And I think the adults need to stop making so much noise that distracts, you know, from what's really important.